2.
Hi, we're now actually on Friday, April 10th, 2020. And we're going back into 11.5. The last class we did some problems on exponentials, some homework problems. But now we're back into some practical problems, elasticity of demand, and then we will do a tax problem, just to help you out. Now what we did before, to reiterate, we had this function, p equals 1,000 divided by q plus 1 squared. They gave us the value p equal 19. Want us to find the elasticity of demand, which is minus p over q, dq dp. Well, first I found q. I put q, p in here is 19. We did this time and we solved for q as 6.3, giving us q and p 6.3 comma 19. Now we need dq dp. Well, I could find dq dp by implicit differentiation, but I'm going to do a little trick. I'm going to use this formula and find dp dq first. So dp dq is going to be the derivative of this function with respect to q, and we're going to use the quotient rule. So dp dq is the bottom, q plus 2 squared, times the derivative of the top, which is 1,000, minus the top, 1,000 times the derivative of the bottom, which is q plus 1 squared, divided by the bottom squared, which you're going to see is going to be q plus 1 to the 4th. All right, so now we have q plus 1 squared, 0 minus 1,000, and I still have this a factor here that I have to work on. So I'm going to do that over here. A comes over here, the chain rule. The chain rule formula is dp dq, na u n minus 1 du dq. So in this case, we're going to have u equals q plus 1, du dq equals 1, n equals 2, and a has a 1 in front of here, so a equals 1. So we don't have to worry about that. So when we find this derivative, dp dq, we get 2 times q plus 1 to the 2 minus 1 times the derivative, which is 1. So it's simply 2 q plus 1. And that's a, and that we're going to substitute back in here. So dq dp comes 0 minus 1,000 times 2 times q plus 1 over q plus 1 to the 4th. Okay, so far we should be right on target. Let me check out what I had before. Let's simplify this just a little bit. First I'll have to erase. So let me erase up to here at least. Okay, we'll leave that on in case you haven't gotten it yet. So what are we going to have here? We're going to have dp dq, I'm sorry. This is not dq dp yet. I'm taking dp dq. I'm taking the derivative of the p. So this is dp dq. Let's change this. I've taken everything with respect to q, because q is on the other side. I didn't have to do it implicitly. So I'm going to get dp dq is going to equal to minus 2,000 q plus 1 divided by q plus 1 to the 4th. I'm going to get rid of the q plus 1. I'm going to divide both sides by q plus 1. the top and the bottom. That means the q plus 1 square cancels, and dp dq goes out to the minus 2,000 over q plus 1 to the third. 1 minus 4. Okay, so that's our bt dp dq. But our elasticity function wants dq dp. So what do I do to dp dq to make it dq dp? Simply, I said dq dp is going to be the reciprocal of dp dq. Let me make this better here, better q. Okay, so all I have to do is do 1 over minus 2,000 q plus 1 to the third. Now, I know a lot of people have problems with this, but when I do this, I keep the numerator the same, and I flip the denominator. So dq dp turns out to be q plus 1 to the third over minus 2,000. And that's my dq dp. See, all I did is I found dp dq, and I flipped it, took the reciprocal, which is perfectly logical, perfectly allowable, and this is my dq dp. So now, in order to know I need a value for this, I have to substitute q equals 6.3 and p equals 19. So dq dp is going to be 6.3 plus 1 to the cubed minus 2,000. And I believe I have done this. That's going to be 7.3 to the cubed. It's going to be 357. So minus 357 divided by 2,000 equals minus 0.179. Now I still don't have the elasticity, because the elasticity equation says it's going to be minus p over q times dq dp. So we have to use, p was 19, q was 6.3, I believe. 3. And dq dp is minus 0.179. We're going to get a positive. And I haven't done that, so I'm going to get my calculator and do that out right now. Okay. It works better when it's turned on. We have 0.54. This comes out to positive 0.546, which is, are we talking about 0 or 1 here? Remember? We're talking about 1, right? Well, this is less than 1. So this is inelastic. Which means what? Which means that it's not too volatile to price. So it could be a prescription drug, a deadly drug. So it's not volatile price. Consumers will demand it anyway within a certain normal price limit. So that tells you the elasticity of demand. We did something different here. We solved for dP/dQ and found dQ/dP by taking the reciprocal. We could have solved for dQ/dP by doing implicit differentiation and the product rule. I decided to do that this way. So let's go on to another problem. I'm going to leave this on the bottom here. And there's a problem where we're going to have to use implicit differentiation.
Oh, you got 3 minutes. No, 4 minutes, I'm sorry.
Okay, so here's another problem. Let's say 2. I want to find the elasticity of demand given I have 2 p squared q equals 10,000 plus 9,000 p cubed. And I want to find the elasticity of demand. And I have to figure out, well, what this problem gives us. Yes, it does. It actually gives us both. It gives us Q, a pretty big number, 4502, and P, 50. Okay, so I'm going to find dQ/dP directly this time, and I'm going to use implicit differentiation. So what I'm going to do is bring everything to the left side. Makes it a lot easier for me. Now I'm going to take the derivative of everything with respect to Q.
Is that all equal to 0?
I'm sorry, this is equal to 0. Now I'm going to find the derivative with respect to P of everything, because I want to find, what I want to find is dQ dP there. So I'm going to do everything with respect to P, and this is 2p squared q minus ddp, 10,000, which is going to be 0, minus ddp, 9,000 p cubed. Okay.
90 seconds.
Now, notice the first term is a product rule. So let's set this up as the derivative, the first term, times the derivative of the second term with respect to p, plus the second term times the derivative of the first term with respect to p squared. This we know is going to become 0.
45 seconds.
ddp, and we're going to have minus ddp 9,000 p cubed equals 0, and we'll return in the next 15 minutes.